if you mix anything into water, it's going to change the boiling point. No matter salt, sugar, anything that dissolves into water is going to change the boiling point. And it's going to go up. There's exceptions for almost everything in chemistry. There may be exceptions for this. I don't know of any. Okay, so the concept is very simple. We put salt in water, sugar in water, boiling point goes up. The math is a little bit difficult, but it's basically everything we've done up to this point and then one more step. So, all right, here's the equation. The change in temperature of the boiling point. Delta T means change in temperature, the little b means boiling point. Equals some constant, the little b again, is for boiling. We'll have another constant tomorrow for freezing point, or melting point, times the, what am I going to use here? Mole, so molality, I'm going to abbreviate mole, and I'm going to put as a subscript particles. So this is the molality, which is concentration, but not the concentration of the compound, but the concentration of individual particles. That means if it's an ionic compound, we have to multiply by 2 or 3 like we did yesterday, that kind of thing. Let me write these out just so you don't think you have them written. So delta T, change in boiling point. That's what delta T, is what B is. And then KB, I told you, is a constant, and I'll give you the number. For water, it's always going to be 0.512, and it's degrees Celsius per mole. So when we multiply by molality, we get degrees Celsius, which is what we want. How much the boiling point goes up in degrees Celsius. Obviously, if it was Fahrenheit, it would be a different number, like 0.9 or 1 or something. Okay, so this is always this number. It's a constant for water. If we had alcohol or oil or some other solvent, we would have a different number. Okay, let's start here. All right, so we're going to do a problem with this, and I'm only doing one problem, so make sure you write neat. All right, so example 1. If we add 200 grams of sodium chloride, seems like I always use table salt, I don't know why, or whatever, to 600 grams of water, here. How much does the boiling point, or BP, go up? All right. So let's do this one step at a time here. So first we're going to find molality. So that means we've got to find mass of the solution. We've got to find number of moles, right? So mass of solution is going to be just 200 plus 600. The mass of the salt plus the mass of the water. That equals 800 grams. And then we got to convert that to kilograms. How much is that? 0.8, right? We just divide by 1,000, so we get 0.8 kilograms. All right, so that's the mass of our solution. The other thing we want to find is number of moles of the solute, which is sodium chloride. Number of moles, I'm going to put of SOL for solute. I put a subscript for a reason, we'll see in a second. All right, so number of moles, that's mass divided by molar mass. So that's going to be 200 grams, the mass of the salt, divided by the molar mass of salt, which is, well, in this case, it's sodium and chlorine, 23 and 35, so that's 58, right? Mm-hmm. All right. Everybody know where this came from?
Yep.
Periodic table, right?
Yep.
Okay. 200 divided by 58, what's that?
Each right here.
3.4.
3.44?
Yeah. Well, it's 3.448, so we're going to do 3.4.
45?
I'll just let you laugh.
Okay, now, before we find molality, there's one extra thing we've got to do. Remember I told you this is the concentration of particles that we want. So that means we don't want number of moles of the solute, we want number of moles of particles, which means we got to multiply this number by 2. Right? From yesterday? Remember that? So times 2, because it's ionic. If it was covalent, we wouldn't multiply by 2. And so, number of moles of particles is going to be 3.45 times 2, that's 6.9, right?
Mm-hmm.
That's the moles that we're going to use to find molality. All right, so now I'm going to come over here. I'm going to erase the bottom. You should rewrite this equation, and then we're going to plug numbers into it. So write this down here. Okay, so our goal is to find this. Oh, wait, I'm sorry. Let me stop for a second. We don't have molality yet, do we?
Nope.
Okay, so we got to find molality. Let's find that first. So, molality, by mole, that's good enough, is what?
Delta T divided by
No, not this. The equation from the other day. Mass of the solution. Yeah, thank you. Number of moles over mass of the solution, right? So this is from 2 days ago. We were using that to find molality. This is going to be 6.9 moles over, no, mass of the solution. 0.8 kilograms. And somebody tell me what that is.
8.625.
8.625 mole. I'm running out of space here. Mole. Okay, so we found molality.
Mm-hmm.
Up till here, we've actually done all this already, right? So now we're just going to take this and plug it into that equation to find the change in the temperature of the boiling point. So now, write this equation. Delta T equals, Kb is a constant, 0.517 degrees Celsius per mole times what we just found, 8.625 mole. And what's that come out to? I'll take a minute, so we're probably supposed to. 0.512 times 8.625.
4.416. Yeah.
4 point, what?
4.416.
416, let's make it 42 degrees Celsius. So this is how much the boiling point went up by. So that means the new boiling point would be 100 plus that, so it would be 104.42 degrees Celsius.
That's a lot.
It is a lot.
So we done?
Yeah, questions? One second, not yet. All right, just real quick review. Found the mass of the solution,
Gotcha.
found number of moles.
Mm-hmm.
Had to multiply by 2 because it's ionic. So what number of moles of particles? We took number of moles and mass of the solution, found molality, plug that in here times Kb, that gives us change in boiling point. Good? All right, turn it on. 4 problems and then 1 question. Yeah.